Okay, in this video we're going to introduce and talk about something called the discriminant. The discriminant is a tool that we're going to use very simply in this course just to identify the number and types of solutions that a quadratic function will have. So let me talk about kind of what I mean. In the past we talked specifically about a quadratic function and its graph. We said there's a couple different situations that we could have. Let me use this line tool, see if it'll make some straight lines for me. So I'm going to draw just each of the situations and talk about it, and then let's talk about algebraically how the discriminant gives us that same information. So first of all, if I have, oops, I'm still on that crazy line tool. If I have a graph and I have some sort of parabola that's graphed on here, we said that when it crosses, when my parabola, pretend that's symmetric, crosses the x-axis twice, right? There are two x-intercepts that we can observe, and if there are two x-intercepts, that means that there must be those two real solutions, and the solutions were the value at which it crossed. So if this was at -5 and this was at +3, then we would state that the solutions were -5 and +3. And algebraically, when we solve that equation, those would be the two solutions that showed up. The other scenario that could happen, so if this is my coordinate axes x and y, is that my parabola could be sitting on the x-axis. I'm sorry if these are not perfectly symmetric there. But let's say this is sitting on the x-axis, so in this case there's only one x-intercept that can be observed. In this case we say that there's one real solution, or in other words, if we were solving algebraically, it would be a repeated solution. And let's say this is hitting at 4, 1, 2, 3, 4. We would just state that x is equal to 4. Now, repeated solution, let me explain quickly what I mean by that. If you have an equation that looks something like, when you factor it, 0 equals, and it doesn't even matter what your a value is, but if you had like x minus 4 and x minus 4, when you factored that, then if you were stating the solutions, you'd notice that, well, if I look at this piece and I'm solving, x is a +4, but it's also a +4 here. So we wouldn't say there's two solutions, both are +4. There's just one solution and it's +4, but it's a repeated root. Okay, so that's what that looks like. And then kind of our last scenario with our solutions was when our parabola was either completely above or completely below the x-axis. So if it looked something like this, right? And in this case, there are 0 x-intercepts. It never actually touches or crosses the x-axis. So there are actually 0 real roots. If we were solving this, we couldn't find any real number solutions, right? That x-axis represents that real number line. However, there are two imaginary solutions. So we discussed this and just kind of said we'd talk about it later. But there are two imaginary solutions. So this is one of those, if I were to solve this, I would get x is equal to, and there would be an I somewhere in my answer. So it would be plus or minus 3i or something like that. Now that does not match that graph up above necessarily. But if this is the solution, then I know that there's a positive and a negative version of that solution. So there are two imaginary solutions. So when we graph a function, that's the first way that we can tell, right, the number, so again 2 or 1 or 2, and the type, so imaginary, a real solution or a real solution. So that's what we talk about, number and type of solutions, okay? We can also tell algebraically using what we call the discriminant, so I'm going to define that down here. So the discriminant here, and I'm going to use, okay, that's crazy, the Greek letter delta to define the discriminant. The discriminant is equal to, and again, this is from standard form of a quadratic, so let me write standard form really quickly. Ax squared plus bx plus c. It comes from the relationship of b squared and subtracting 4 times the a value times the c. Now what I want you to notice is this should look pretty familiar, right? B squared minus 4ac comes from our quadratic formula song. Notice in the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So if you notice right inside here, that's what we call the discriminant. Okay, so let's talk about what it can tell us. Okay, why would the value under the square root, why would that particular piece of our solution tell us what kind of roots it's going to have? So let's consider a couple options. Well, inside a square root, as we just talked about in the last video, if you have, right, a positive number in here, you're going to have real number solutions. So if there's a positive number found underneath my radical, great, I simplify the radical. Those are my solutions. Now, because the quadratic formula, right, has that plus or minus involved there, then that creates two different solutions there. If we have, I'm going to draw the plus or minus again, a negative number inside here, so this is a negative number. As we talked in the last video, that negative is what we represent with an I. So that's where we would understand that there would be two imaginary solutions. Okay. And then that third scenario, right, up here we had three scenarios on our graphs. So again, positive number. If there's a positive number in there, it looks like it's going to have two solutions. If there's a negative number, that would be this scenario where there's two imaginary solutions. So what about this third scenario? Well, the third scenario, there's only one solution. So if we consider that plus or minus, right, and then this radical, how would we get rid of that plus or minus to create one solution? And the answer is if you calculate the discriminant and you get a 0 inside. If you get a 0 inside, the square root of 0 is 0. So that piece of the quadratic formula just simplifies away, and I'm going to show you what that looks like. So this is the case, right, when there's just the one solution. So let's just kind of look at a little bit of this. So if I have an equation, again, that is something like, let's just look at an example. Let's do 2x squared plus 3x minus 1 is equal to 0. Again, if I want to calculate the discriminant, I need to use the a, b, and c values, so make sure that it's equal to 0 first. In this case, the a, right, is equal to 2, b is equal to 3, and c is equal to negative 1. So if I want to calculate the discriminant, I'm going to write this right here. So anytime I'm asked to do that, I'm going to go ahead and say, well, the discriminant is equal to b squared minus 4 times a times c. So the discriminant here is going to be equal to my b value, which is 3 squared, minus 4 times the a, which is 2, times the c, which is negative 1. So here we have 9 minus, I have 4 times 2 is 8, times a negative 1, though, is a positive 8. So in this case, our discriminant is equal to 17. Now, again, if the discriminant is equal to 17, that's a positive value. So that means that there are going to be two real number solutions, right? Because if 17 is the number in the radical, there's no imaginary numbers needed. Now, let me show you with the quadratic formula how that plays into the solution. So if I was solving, so now let's say I'm just solving the equation, I'm going to plug it into the entire quadratic formula. So I'm going to have negative 3, because we do opposite of b, plus or minus the square root of b squared minus 4ac, which I just calculated as 17. So I'm actually going to write the square root of 17. And then we're going to go all over 2a, and the a value is 2. So if I'm calculating the solution here, I have negative 3 plus or minus the square root of 17 all over 4. Notice here, I have two real solutions. There's no imaginary number involved, so there's no need for the I. And in this case, any positive number would give me that same scenario or that same situation. Okay. Let's maybe look at one more. I'm going to run out of room down here, but we'll see if I can fit one more. Let's look at maybe x squared. Let's go minus 6x plus 36 is equal to 0. Again, if I were asked to, I'm going to write it out so we get used to those instructions, but calculate the discriminant. Again, I would say, well, the discriminant is equal to, and I would do b squared minus 4 times the a value, which in this case is 1, and the c value, which is 36. Now, if we look at this one, we're looking at negative 6 squared, right, which is 36, minus 4 times a times c. And it looks like we have negative 108. Again, if the discriminant is equal to negative 108, that's a negative value that would be stuck in my radical. So in this case, there would be two imaginary solutions, or imaginary number solutions, okay? And let me show you just right over here kind of what that would look like once again. We would have x is equal to negative b. B is negative 6, so I'm going to use positive 6. Plus or minus, we just found that that's negative 108 in there, all over 2a, and a was 1. So in this case, I have 6 plus or minus, and I would simplify that radical. And again, part of simplifying is bringing that I value out with the negative. And then I could break down 108. So that would be like 12 times 9. So I've got some 3's there. I've got 4 times 3, so I've got some 2's here. So 2 times 3, I'm going to bring a 6 out as well as that I, and leave that 3 inside. And then remember, we always look at those 3 numbers and simplify, so I'm definitely out of room here. But it would be equal to, all of those are divisible by 2, so we'd have 3 plus or minus 3i squared root of 3, all over 1. So I won't write the 1. But notice here, again, we had an imaginary solution, 2 of them, a positive and a negative, because that negative number showed up as our discriminant. So there's those 3 scenarios, and again, I'm just going to write them off to the side right here. If the discriminant is greater than 0, so it's a positive number, then we have 2 real roots or solutions. Remember, those are interchangeable. If the discriminant is less than 0, if it's a negative number, then we have 2 imaginary roots or solutions. And then if the discriminant is equal to 0, that's the scenario where we have the 1 real solution. Maybe I'll quickly go through one scenario of those. But this right here is what you're going to want to remember as you're identifying that. Let's see if I can add a page in here. Oh, there we go. Okay, let's do the last example here. So let's say we have x squared plus 10x plus 25. So again, if I want to calculate the discriminant, we're going to have, I'm going to write these out. A is 1, B is 10, C is 25. So b squared, we have 10 squared minus 4 times a times c. Notice here we have 100 minus 4 times 1 is 4 times 25, so 100. So in this case, the discriminant is equal to 0. So this is one where I know it's going to have 1 real solution. And let's solve it and kind of look what that looks like. So, because this one maybe is the funkier looking one. If we're going to solve this one with the quadratic formula, we would do negative 10 plus or minus the square root of 10 squared minus 4ac. Oh, I already calculated that, right? I'm in such a habit of writing that out. So we get 0 in here, all over 2 times a. So notice here I have negative 10. If I have plus or minus 0, right? If I add 0 or minus 0 from anything, it doesn't actually change the value. So this is where that doesn't even get included anymore, and it's just all over 2. So notice this is just negative 5. So when you solve this one, there's only one value that comes out because that plus or minus that creates the two solutions goes away. So again, if you're asked to calculate the discriminant, you just think about the part inside the radical from that quadratic formula, and then think about what the solutions would look like based on that. And hopefully that'll help you.